Welcome, everybody. We're following up vBrownBag with Objective 2.1. Today we have Paul Cradduck, recent VCDX. Paul, would you give us a little introduction about yourself and tell us about when you got the VCDX?
Yeah, absolutely. Thank you for having me today. Yep, I am VCX number 244. So I just defended the end of last year, and it was quite a process. I'll definitely say that I owe of my three numbers. I think I owe one number completely to the community. vBrownBag and just a lot of the VCDX community that really poured in. To me to support me and help out, so that was awesome. My second number I owe to my teammates Tony Gonzalez and Alex Carrera, and who are currently still working on theirs, but huge support there. Rebecca as well grilled me for a day before before my defense. That was great. And then my wife probably owns the third number, so I'm not sure I even have a real number at the end of the list. But
I really appreciate that you mentioned it right from the get-go that this is something that um, you know, it's a whole journey, and I'm glad that you're here giving back to the community. So thank you so much.
no,
Uh,
thank you guys.
I actually do have some little announcements, just the same ones as always. If you have any questions, and even if you are attending live or if you see the recording later on, you can reach out to Paul at P Craddock on Twitter. And you can also ask vBrownBag for anything. If you need any help, we'll try to get you to the proper person. You can use the hashtags, hashtag vBrownBag, or you can use the handles. Remember, we have several channels. Even though we're doing it in US time, this is the EMEA channel. It's on Tuesdays. US is on Wednesdays. I think we have Mike Foley tomorrow. LATAM is on Thursdays. I think we're finishing something with OpenStack there. So, separate paths, but basically you can get as much vBrownBag as you want. And lastly, we are still looking for presenters. We're looking for other, especially VCDXs who have gone up and down through this blueprint for their mocks and their defenses. But anyone can actually ask us, hey, I really like this topic. I think I'm good at it. I go ahead and present it. We're open. This is really the community that really makes the material and makes the good presentations. We're looking forward to what you can do. With that, I'm going to go ahead and switch over control to Paul, and I'll shut up, and we will be able to, get all the knowledge.
All right, let's see if this works. Works first time here. Let me know when you can see that.
I can see it.
Perfect. All right. So as we already covered, my Twitter handle and VCX number. I'm a senior cloud and DevOps architect at Round Tower Technologies, and we're going to go through Objective 2.1, and it's mapping business requirements to our vSphere logical designs. So the agenda, and we already said it, but I just want to thank everyone, especially within the community. It's huge. I don't know how anyone has gotten their VCDXs without community support. So I think we already touched on that, but just to echo that again. And our intended audiences. So really tonight, I've got two things in mind. There's two sets of people, right? There's people that want to take and pass their VCAP because they currently do design work and they're just wanting to validate that that work that they do and want to just learn a little more. And then there's people that are taking this because they love it and then they want to take it to the next level and engage in the VCDX program. And so there's two kind of audiences that I'm going to be speaking to tonight, and so that's kind of the intended audience, and we might switch between. I'll point out things as through the presentation that might be more useful on the VCDX versus in real world versus maybe the VCAPs. So set up here, we're gonna define some what I call RCARs. That's how I remember them. Just similar to ramps. So that's just an acronym I use to remember it. So and we'll define the ramps. We'll define conceptual, logical, and physical, and we'll define current state. And we do that because we really can't map requirements into a logical design if we don't know what those different pieces look like. We'll then dig into requirements. We'll hit functional versus non-functional, and then we're going to do some practice. I think practice really helps, especially on trickier things like the functional versus non-functional. I watched Rebecca's vBrownBag last week, and she did an awesome job digging into these, and this is just a tough subject. So hopefully I can reinforce some of the groundwork she laid. And then we're going to go through and help to translate some of the stated requirements into logical designs. That's really going to come in useful at the VCAP level, definitely, again, in VCX, and most importantly, if you get into real-world designs and you're in front of your client, to be able to translate what the business wants into some of those designs and technical features to support them. And then we'll just remember to incorporate the current state of the environment into what we're trying to design. So we'll jump into it. So, okay, our cars. I'm not going to spend a ton of time on this because we probably know a decent amount about what these are. So, and again, last week's was awesome. But just to rehash, requirements are things that our design must do, regardless of how it ends up. It has to meet these things, these functions, these these things. So we'll get into some examples of all this in the next slide. So I just want to run through this. Constraints. These are things that limit my choices. So if I'm designing a storage system, I am limited maybe by the type of storage or the vendor or something like that. So anything that limits a choice that I can make is a constraint. Now, there's assumptions that we have to make as architects. We should do our very best to not have assumptions that we can't validate. But at the end of the day, there are some things that we can ask the question, but we really just have to trust, right? So, and I've got some good examples of this, but one that pops into my mind is just like power. I can ask the data center manager and say, hey, I'm bringing in 20 servers and roughly going to be this much of a draw, this much, for all of them. Do you have enough power in place for those? And he says, yes. I have to kind of trust him because I can't actually put that load on the system. I can't actually know, I can check the number of plugs, but I don't really know underneath. So I have to maybe list that as an assumption, list who told it to me. And by the end, hopefully by the time I've implemented, I know that's not an assumption because all my servers are on, things like that. Risks. These are things that, exactly what you think, that impose issues to the design that could cause problems later down the road. So let's jump into a couple of examples here. So, in this diagram here, I've got example requirements first, and one of the things I do in real world examples is I actually put IDs in when I'm listing these things out on my designs. I assign arbitrary IDs. And that's going to help you later on, and I'll get to that later in other slides, but that helps me to map everything out, which is pretty key. So an example of a requirement here. The design should avoid any single point of failure. Now that is actually, that's a requirement. It's a little bit vague, but it is a requirement. So I might want to ask some more questions of my client before I just wrote that down, but maybe that's all I'm given. And especially on your VCAP, you're not going to be able to ask questions to the test. So you do have to just take it a little bit for face value. But certainly in the VCX or when you're designing for real world, you want to try to get as much detail as possible. The next one. Design should account for 20% growth of CPU, memory, network, and storage over the next 3 years. That's a great requirement. It's very specific, exact percentages. I know exactly what I'm designing for, and I know the period of time that I'm designing for. So that helps me a lot to be able to get my calculations, pull the statistics out of the current environment, or if it's not existing, run some simulations with some tools. But I can prove that out. That's a good requirement. Constraint. The design must use rack mount form factor. So this is a constraint that a client would put on me. That is going to limit me. I won't be able to use blades at all. I have to use full rack mount, and for whatever reason. It's worth noting that you might want to have discussions with your clients about these, like, hey, why is that a problem? Maybe it's something with legacy. Maybe they just had a bad experience with blades. Who knows? But maybe worth asking. But it is a constraint that if it stands, I have to follow. Another one is the design must fit into a single 48U rack. That's totally a valid constraint. Maybe it's a colo. Maybe they only have one rack, right? So next is an assumption. And like we sort of said before, the data center has proper cooling in place for new infrastructure. I should ask that question. I should say, I'm bringing in this much infrastructure. Is the cooling in place to take care of this? But at the end of the day, I can't actually test that. I just can, ask the question clearly, document, tell me the answer, and then kind of work from there. and then risk. Now, this one's interesting because your risk is actually a constraint as well. And this is an example of where you can have a constraint that actually imposes a risk on your design. So in this particular example, everything in one rack is a single point of failure. So you, as an architect, need to kind of be able to think about that and say, well, you put a constraint on me that we have this 48U rack I have to fit into. Everything has to fit into it. We're in a colo. That's a constraint. But you should know that if there's some sort of, like, let's say there's a water pipe on top of the rack that bursts, I don't know, whatever, there's a million things that could happen. That is a single point of failure. All the redundancy I built in means nothing if the rack is completely compromised. So, and that they may or may not be able to change it, but if you call that out, then the business can say, ooh, that is a good point, we need to change that, or, you know what, we're willing to take the gamble, go ahead with that, you just document it and move on. Okay, design qualities. So these are not necessarily, these are different than your RCARs. These are things that more describe how the system should function, and in recoverability, availability, manageability, performance, and security. And those are kind of what they sound like. Your recoverability, how are you going to address the ability to recover after a disaster? You know, from backups, from other type of things. Availability, how does your, you know, if you lose half your infrastructure, is your application still available? If you put up, you know, enough redundancy in, hopefully. Manageability, how do you turn VMs on and off? How do you turn servers on and off, you know, through different out-of-band management solutions, you know, whatever that is. Performance. And performance can be a lot of different things depending on the design and what you're scaling, what you're designing for. Is it IOPS? Is it response time? Is it latency? Is it throughput? Is it web? You know, is it a web application and you're supposed to have so many users per? All these different things kind of play in. And security. You know, and that is, again, it's pretty self-explanatory. Is it secure? Am I sticking my web server straight on the internet with no firewall? That might not be a great idea. So we'll kind of move on. And if at any point, I don't know if people have the ability to talk, but if you have questions, certainly kind of interrupt me, and there will be some places for feedback as well.
Yeah, so basically anybody can raise a hand, or they can also tweet us, and I'll be able to grab that and I'll stop you and I'll let you know.
Perfect, that's great. All right, so let's look at conceptual versus logical. So this is a design that I kind of threw together real quick. So conceptual on the left here is completely there's no connections here. There's no brands. There's nothing here. It's simply me saying I have a data center. I've got hosts. I've got storage. That storage is replicated, some of it at least. On top of my hosts, they serve up networks. They allow me to put the host together. I make a cluster, and then on top of those, I have VMs that provide services. Right? And that's a completely valid conceptual design. It's just an idea of all the things I need to have within my design. Moving a little deeper into that, now we have our logical design, and this is where we're really going to spend the focus tonight of our topic here. Is we're moving a little down. I'm showing now I have a vCenter. I've got that management layer. I'm showing a host, showing multiple connections with an onboard and a PCI NIC. I'm showing connections out to core A and B, so some switches. I'm showing cross connections between those switches. And I've got looks like probably an NFS or iSCSI storage array. And I've got the redundant service processors also cross-connected into all of this. Now I don't have any brands. I don't have any features here. I don't have a whole lot. But what I'm getting is that next layer down. Here's how I'm thinking as an architect that I'm going to begin to build a skeleton of my infrastructure. Okay. And then lastly, the physical. And this is the one that takes, if you've done a good job in your conceptual and logical, this doesn't take you as much time. But now I'm actually showing my servers. I'm showing my connections on to my servers. I'm showing the physical cross connections between my core, right? My peer links. I've got 4 of them. I'm showing the storage arrays. I'm showing I've got LACP in place here on these arrays. I've got management, where they're connecting at. I've got speed of connectivity, and now I'm really into the physical nuts and bolts of how someone should connect this. This is a little bit of a limited one. You might even show rack elevation. You might even show what ports specifically you plugged into so people can go back to. Now this last one here, this is a nice to have. And you might get this, but you might end up building it for yourself. And I find this to be a very useful tool if you can get it, or you may end up building it, like I said. This is a potential current state layout for a customer, right? We've seen that we've got some management servers on the top, and it's fairly stripped down for this example, but now I've got an application cluster, a DMZ cluster, and on the other side I've got my dev cluster, my DMZ cluster. My networking, I've got my switches, I've got UCS fabric interconnects, I've got different VLANs mapped out. It looks like I've got some connectivity between the two sites with that 20 gig link. I've got storage at the bottom with NFS, RDM, CIFS, VMFS. On the other side, I've got very similar, and then I've got an extra array. So this is something that is very useful if you can get it to begin your design with, because now you have some ideas. There's some things you can take out of this and utilize. But if you don't get it, like I said, it might be helpful to build it out because it may help you when you're actually going through architecting. What are some gotchas? And we'll get into some of that here in a minute. Okay. So some prerequisites before we just jump into designing. Do not start designing before you know as much as possible. And that holds true not only for your VCAP, and for your VCDX, and just as much in real life. Do not start designing until you know as much information as possible. And I know this is a problem for me. I wear two hats. I'm an engineer and I'm an architect. And my engineer hat wants to hear a business requirement, hear a need, and instantly, boom, my brain is, without even me doing anything, I'm just, this solution, this software feature, here's how I'll put these things together. Try really to stop yourself from doing that. Try to stay in that information gathering phase and reread if it's written down, or ask those next questions before you're just assuming things. That will go a long way in your VCAP. It'll go a long way in your VCDX. The next thing that is massive is traceability. This will help you. I mean, a little bit in your VCAP, but it is huge in your VCDX and in real world, I would say, is why did I make the choices I made? What business requirement, what constraint, what assumption, what risk, what led me to make the choices I made, right? If I can't tell you why I did what I did, and I deliver something that looks like this, I need to be able to justify why I delivered that. If that looks fancy, but if the customer didn't ask me to do that, and I show up with this, they're not going to be happy with it. They're not going to be able to run it. It's going to be hard for them to find the one blade they wanted to use amongst the other things. On the other hand, if I can easily show you there was a business requirement to have nail clippers and a pocket knife, then that's what the customer wanted, and I can show traceability for that, great. No one can tell me that's not what they wanted. I've clearly defined it. I've reviewed that with them. They said, "Oh, this is awesome," and that is huge in your VCDX. If you can't, you might be able to throw in all the solutions and make it super fancy, but if you can't show me why you did it, then it's over-engineered. You potentially took too long to implement it. It's hard for the customer to manage. It costs too much, whatever. But we don't want to end up building that if that's not what we're going for.
That's an excellent example, and love the image. One thing with traceability, do you also, I mean, one of the things about information gathering, you also have to be sure of who said what and what their position in the company was, right? So how do you how do you handle it when it's just a rumor and you have to basically go and figure out if the network is this or the security person is really this, so that you can actually write it down on paper and it's not just something offhand you heard?
Absolutely. I'm making sure when I'm doing these that I'm interviewing. Hopefully the business has brought me in, and I know my internal stakeholders. I know the people within the business. That if I'm brought in and I have a chance to talk to like the VP of technology and things like that, I'm gathering what he really cares about. Or he or she, I'm gathering those requirements, and then I'm saying, hey, all right, I need to validate a lot of this. Who are my point people for your network? Who is the point person for your storage? Who should I talk to about an application, about what about the VMware environment. Who should I talk to about all these things and interview those people? And during those interviews, I'm writing that stuff down, and I'm saying, hey, when I talk to Mr. or Mrs. VP, they told me this. I just want to double check that with you. Do you think you think that's okay? Yeah, great. Or they told me this, and maybe your VP doesn't know this, but you and I as engineers know that means this. Is this true? And I'm documenting that. I'm writing that down, and I'm recording who said it, and that way I can go back to it later and be able to lean on that if something goes sideways, or if one of those assumptions that I made. Because when I'm really interviewing, like I said, those can be assumptions. At the end of the day, I have to trust what they say if I don't have physical access to test it myself. If a network guy tells me he has enough bandwidth, but I don't have access to deploy some sort of bandwidth monitor solution, I have to trust that that's what they have. And so yeah, just kind of document that.
Awesome, thank you.
Yeah, and I think the only quick point there is if there's conflicting information, just bring it up. Just say, hey, person A over here told me this, and you're telling me this. Which one is true? And just kind of cross-check that stuff with, just try to get clarity as much as possible on that. So, yep. All right, so let's jump in here. So let's look at functional versus non-functional requirements. So we already defined requirement. Now a functional requirement is something that specifies a function that a system or component must perform, right? An example of this is the design must be PCI compliant, right? One of the ways to quickly identify a functional requirement is it's going to be more of a business thing. It's not so much technical. Yeah, PCI compliancy has technical implications, but to define PCI, PCI is the payment card industry's standards for things like credit card processors that have to comply with. So those do have technical implications, but to the business, that is critical to their business. So that is a functional requirement. It doesn't put so many constraints on me. It just says here's something that the system must be able to do, and we've got some more examples coming later. So a non-functional requirement. Now this is something that states how the system behaves. It's almost a constraint upon the system behavior, and that's how I identify these things. And here's an example. The design should account for 20% of growth, CPU, memory, network, and storage over the next 3 years. Now, so this was one of our earlier ones, and I would classify that as a non-functional requirement. It's not so much telling me what the system does, it's telling me how it has to do it. And I wouldn't list this as a constraint. It's not constraining to me. It's not telling me how I need to design for that. It's just telling me I need to design for it. It is a little limiting because maybe that means I can't use some of the things I was thinking in the back of my head because it doesn't scale as well as high as I need to. But that's not necessarily a constraint. It's just one of those non-functional requirements. So if it sounds a little constraining but not a constraint, that's probably more of a non-functional requirement. They generally have metrics in them. So in this case, 20% over 3 years. Generally, you're going to see those things as a non-functional requirement. All right, so let's continue here a little bit, and I've got some more examples that hopefully will help clear this up and let us more clearly understand this topic. So a functional requirement. Let's get out of IT for a second and just say that the design must allow for proper working conditions for our delivery drivers in the summer. Okay, that's a functional requirement. They're not telling me how to do it. They're not constraining me. It's just how the system has to work. I have to produce proper working conditions for delivery drivers during the summer. By that functional requirement, this picture is completely true. It's totally fine, right? It's probably not what they were going for, and I wouldn't deliver this. But a home air conditioner stuck in the back of a van technically fits that requirement. And this is a bit of a lesson for us as we get into the VCAP for sure, and also the VCDX in real life. Ask the next question, because there's probably a non-functional requirement that will help support the function of the system that will help you drive what you actually wanted to deliver, what the customer actually wanted. So if you asked a follow-up question with this, and I came to this non-functional requirement, design must be built into the dashboard of the van and cooled to a temperature of 68 degrees, now we're a non-functional requirement. It's telling me how the system has to function. It's telling me it must be built into the to the dashboard. It's telling me how cool it has to make the van. Now I can take that and actually maybe do some architecture around it. It's constrained me a little bit because I have to go with something built into the van, but it's not so much a constraint because I can choose all kinds of ways to do that, right? They're not telling me exactly how to do it. They're just saying, please don't stick a home air conditioner in the back of our van. So let's do a little practice here of functional versus non-functional requirements. And so we'll need a little audience participation. I don't know how many people are on the line, so we'll just jump in.
All right.
So first one, the design should allow for auditing of all user actions within compute systems, within the compute systems. We thinking functional or non-functional?
That's functional. You're not being told how to do it. You're not being constrained in the requirement. You don't have any metrics. So.
Absolutely. Yep. Functional. Completely agree. And for the exact reasons you said, you're free to do whatever, however you want to do that. All right. Another one. The design must allow for backups.
All right. I don't know if Elon wants to participate. I see that he's muted. So if he wants to unmute and participate, you can go ahead.
Yeah, feel free. Elon, you got an answer for that one?
Yes. Hi guys.
Hello.
Hi.
Hi. Design must be allow for backups. Functional.
Yep. Completely agree. Yeah. I would say that is a functional requirement. It's not constraining you on how to do it. It's just saying that the design must perform this particular function. All right, next one. The backup storage system must be able to dedupe data by at least 3x. Functional or non-functional?
That's all yours, Elon. Elon, do you want it?
Yeah, no problem. The backup. Sorry. Yes, it's also functional as well.
You think? So,
Yes.
so I'm going to call that one non-functional,
Okay.
and here's why. Because within that requirement, I have now, first of all, I've added metrics and I've constrained you by telling you now you have to choose a backup system that not only deduplicates the data, because the first one didn't. I mean, backups don't have to be deduped. The first one was just functional because I just said back it up. This one is telling me I have to find something that dedupes, and also I have to find something that dedupes at a 3x compression, at a 3x ratio. That may or may not allow me to do some VM products. Maybe I have to go to the physical appliance to get that kind of ratio. Who knows? But again, that's not so much a constraint, but it's a little constraining on my choices. I can't just put anything in now. So for that reason, I'm calling that one non-functional. Let's hit one more here. The design must not reuse end-of-life hardware or software. What do you think? Functional or non-functional?
No, it's funny because they are constraining you in a sense, but they're not putting. I mean, it's very binary, right? It's not. Don't use any end of life. I'm gonna call it non-functional just because I am constrained and it's very clear.
Yeah, absolutely. I totally agree with that. That is completely a non-functional requirement. It's not telling me exactly what hardware to use. I've got all kinds of choices, but I just can't reuse the old stuff. So I wouldn't put it as a constraint because it's not that constraining, but it's just really a design requirement that we don't want to reuse this old hardware. So good. That's awesome. Great job,
Awesome.
guys.
Thank you, Elon. I'll mute you, but I'll open your mic again if you want to ask any question or anything.
Okay. Let's jump into working functional requirements into a logical design. So let's look at just these couple of requirements. The design should allow for auditing of all all user actions within the compute system, and the design must allow for backup. So these were our two functional requirements from the last slide. Now again, in the VCAP, you will not be able to ask questions, and you might end up with a slide that looks like this. And you have to come up with maybe there's a drag and drop, or maybe you have to design something that fits these. You can't ask more questions. You don't know. However, in real world and in VCDX, you want to ask the follow-up questions because they're going to probably, your non-functional requirements, that deeper level, I also think of functional requirements as like a base, but that non-functional requirement is going to really dictate how I answer those questions. So in the strictest of sense, if I were doing this on a VCAP or if I wasn't allowed to ask any other questions and I just had to design for the two requirements, I might go with something like this, right? It's a 3-host, it's a cluster. I've got my backup server shown. I've got my auditing server shown. In the strictest of senses, I have answered the question. I've met those requirements. I have a backup server and I have an auditing system, and that's great. But again, real world VCDX asks the next question. So let's jump into the next slide. Let's work more of those non-requirements into intellectual design, right? So the first one here, the design must use. Are you guys seeing my next slide? Are you guys seeing?
Actually, yeah. Now I see it.
Yep, there it goes. There it goes. Okay. The bar, the WebEx shows me who's seeing stuff, and it was all red still. So we're good now. All right. So this requirement, the design must use redundant host connections and switch uplinks with no single point of failure. And during a host failure, the business application must return to production within 30 minutes per their SLA. Great. So how do I take those requirements and put those into a logical design? Again, I don't need all the connections or anything, but and you might see something like this on a VCAP. You'll definitely see these things in real life. So how do you translate some of this stuff? So here's one example, right? I've got, again, that 3-host cluster that I built. I've got my onboard NICs. I've got my PCI NIC, so I don't have any single point of failure within a specific NIC. I've got core A and core B, they're cross-connected. So in the strictest of senses, I've met the first non-functional requirement. Now, this goes back to that pocket knife that I talked about. The engineer architect in us might want to say, you know what, I'm going to cross-connect the onboard NIC and the PCI NIC to core A and core B because that's more redundancy. However, that's not required. I met the requirement. Now that might seem like a fine line, but it helps us to not get too fancy for no reason. This requirement just told me to have redundant host connections and switch uplinks so there's no single point of failure. This does that. I don't need more to do that. I've hit that requirement. Okay. But the next requirement, during a host failure, business applications must return to production within 30 minutes per the SLA. Does this design meet that requirement?
It's very difficult to tell, right?
Yeah. So, and this is helpful. So, I would say this design does not meet that requirement, and here's what I would do to meet that requirement. We have to remember not just to think about the hardware and how it would cross connect and all the other things, but we have to think outside the box and think what software features could potentially meet that SLA. So I would take my original, and now I'm going to show that I have HA here, right? Now I could make a pretty good argument that this design could meet, to some extent, the second part. Now, clearly, there are a lot of things missing. I don't know what the storage systems look like. Does that really, how does all that work? I don't know. It's tough to tell. With the information given and potentially on a VCAP, you might not be able to architect the world. But what you want to do is just architect for the things that you know and the things you can see, and technically, yeah, that pretty much meets it. Again, without bringing in the storage, HA will restart my VMs because remember, look at this. You got to read the details here. It says during a host failure, so it's not talking about storage failure. It's not talking about network failure. It's not talking about anything else. It's driving a host failure. So the one feature I have at my disposal to deal with host failure is HA. HA will restart those VMs. And hopefully, pretty good bet it's going to bring them back up within 30 minutes. You can make that case.
Cool.
All right. Oh, question?
No, no, I just thought that it's actually a very good worded requirement that screams HA. You're totally right.
Yeah, thank you. All right, so let's get into some requirements practice real quick here. So I'll go ahead and read this, and read along with me. And this is not that crazy to potentially see on a VCAP, VCDX, or real world, right? Your customers ask you to design infrastructure that's highly resilient and redundant. They can tolerate only about 5 to 10 minutes of downtime, as they lose tens of thousands of dollars every minute they're down. They do want to save money, but if they can justify the cost, they can get what they want. They already have data centers in Chicago and Colorado to allow them to stay alive in the event of a natural disaster. They have plenty of space, power, cooling, and bandwidth in both locations. They want to be able to run out of Chicago normally and only fail over in the event of a site failure. They want to make the best use of resources they have and the infrastructure they purchase. And they want to be able to quickly scale and deploy new infrastructure on demand within Chicago and Colorado data centers. And I realize that is a giant run-on sentence that is recorded forever, so that's all right. All right. So what are some things besides the run-on sentence that jump out at us here? So if I'm putting my engineer hat on hold for a second, and I'm trying to take this business use case and pull out requirements. What are some things that jump out at me right away? So one of the things that hits me right away here is that uptime. That is 5 to 10 minutes of downtime. That's 5 nines of availability, right? Which is about 5.5 minutes of downtime. That's hard. That's going to take some architecting to hit, and it's not going to be cheap. Now they've addressed some of that they've got money in already, and if they can justify it, they can get it because downtime is very costly for them. So that's fine. But we're going to have to. We just have to know that's a pretty big thing we're going to hit. It sounds like they are pretty proud of the fact also that they've got 2 data centers with plenty of space, cooling, power. They feel like they've done you a favor here, so they want you to utilize that. So they said here in the bottom that they really want to run out of Chicago. They only want to fail over if there's a site failure. Who knows? Maybe the Colorado data center, maybe it's a colo and it's just really expensive. Maybe it's something else. Who knows why? But for some reason they want it. Well, so I'm thinking maybe about pitching redundant clusters within Chicago, right? With some sort of a storage, multiple frames, maybe a vSAN, maybe something that allows for me to do failure within Chicago and not have to fail over across the country. Redundant networking, redundant SAN switches, and the list goes on and on, right? I'm pulling out those business requirements of uptime and money and where they might want to run and all those things, and I'm beginning to translate those into real world. How do I as an architect deal with some of that? Now, not only on the physical side, like we just talked about, but we have to also remember the features of vSphere that can facilitate those business requirements, because the customer is never going to tell you, hey, I want to make sure I have HA and DRS. Not at the high C-level VP level. They don't know. They will tell you they want a highly resilient, redundant system, and they want to make proper, they want to make the best use of their resources. So to me, that screams HA and DRS. I want to make sure I can do that. Another huge thing that jumps out here is they want to be able to scale quickly, but within their data centers. Well, distributed switches, because that will quickly allow me to not have to make a ton of changes across all my hosts. Maybe auto deploy. I don't know. I'm not saying that's for sure, but maybe depending on how fast they need to scale up, and maybe I can bring hosts up and down. Maybe I'm charged for power, a little bit at different data centers, and I want to, at my cold site, at Colorado, I want to shut everything down, but I want to boot back up and have everything. Who knows? There's a ton of use cases here for all kinds of software features. So don't throw those things out when you're designing. Make sure you've got the hardware, but also the software in mind to guarantee some things. Go ahead.
One thing that came to mind when they said they want to make the best use of the resources they have and that they want to scale quickly and deploy new infrastructure, I was thinking they might use the Colorado resources for their dev and their tests so that they
Hmm.
don't have to be testing in Chicago.
Yeah, absolutely. Absolutely. That's a great point. And certainly you can see how this kind of a use case in a real world scenario, this drives all kinds of questions. And now we can have really good conversations with our customers and say, hey, what have you guys ever thought about doing this? Because they may not have thought of that. Certainly on a VCAP, you're not going to be able to do that. You're going to have to take what you get. But that's where our conversations would definitely drive. And that's why we don't want to be too close-minded, and we don't want to begin architecting right out of the gate. We want to say, well, what if this happened? What about this? And how we do this? Here's another one. I'm interested in the conversation around this. NSX. Did either of you think maybe NSX is a good fit here?
Well, especially if, when they fail over, they want to keep IP addressing and stuff like that. It really depends a lot on their applications and what we're really protecting. But yeah, it could be that that's the
Yeah.
way to do it.
Yeah. Okay. Yeah, absolutely. It's certainly a really good thought. So what I was thinking is that it's definitely something that I would have a conversation around. Given if I were in a test scenario and this were all I was given, I couldn't ask questions. To me, NSX in this particular example might be a little bit more of that pocket knife we talked about, because it's a really great product. There's a lot of really good use cases for it. But I don't know if I know enough yet to bolt. Certainly, if you have a customer you talk to, you might be able to bolt that on and say this could really drive some value for you. But on a VCAP, I don't know that I would put it in, because I don't see a clear requirement here for anything around networking. They don't say that they want to keep the same IP addresses. They don't say any of that.
You're right.
So a little fuzzy, certainly. So, but it's certainly again, another product set that we can think of. Are there any alarms that you guys see? I mean, anything that's just screaming at you that you're like, there's some problems here.
And Elon, I've opened up your microphone if you want to comment. I don't want to feel like I'm the only one participating.
It's okay if you
No,
don't.
no, I'm reading again and again and trying to figure out if there's something else.
One thing that when you read it the first time, it brought a question to my mind was they want to save money, but if they can justify the cost, they can get what they want. That's a very blanket statement. That can go one way or the other real quick. So what would be those decisions, those design criteria for me?
Yeah, that's a good point. I would definitely have conversations when you have seemingly conflicting ideas on what to do here. I would have to have conversations saying, what does that mean? And that is where I would take the second sentence there, where they talk about they lose tens of thousands of dollars every minute. So they tell me that that they can take up to 10 minutes of downtime. Let's say it's $10,000 a minute. So you're telling me $100,000 for 10 minutes. I'm going to start taking that, because now I can talk to a business person. Now I can talk to a CTO and say, you're telling me that $100,000 is what it's going to cost you to be down for 10 minutes. So I can provide a solution that's going to cost you $75,000 up front. There will be no, but it'll stop you from having to have downtime, and it will save you from having, and it'll shorten your downtime by this much. It'll do whatever. So I'm going to start having conversations around the money side of it to begin to see how far do they really want to go with, if they can justify it, they can get what they want, right? And really start to figure out, what are the boundaries of that statement?
Exactly.
So, yeah.
Which other one were you thinking about?
Yeah, so the alarm, the massive alarm that's screaming to me in this one, is at 99.99% uptime. I missed a 9 there. That's all right. Distance. Their backup site's in Colorado, not Chicago, or in Chicago. There is massive distance between those sites, and in order to hit only 5 minutes of downtime, you're probably gonna have to use synchronous storage, but you won't be able to get latencies that fast with those distances. And this is a point where you need to definitely for the VCAP and for your VCDX and real world too, but VCAP for sure, you need to know those maximums and minimums. You need to know that, I need this many millisecond response time to do this. This much distance. I can go this deep. So that when you're looking through all the things, because the customers, from the way I read this, they think they did me a solid here. They got these amazing data centers in Colorado and Chicago. So if an earthquake hits in one place, they're fine in the other place. They don't realize that means I won't be able to hit that uptime. I just can't. If Chicago goes away, the data, there's potential that there's going to be missing data because I won't have had the time to get it all over there, depending on how big the application is or the database. So I would have to do something like asynchronous replication, and then are they okay with that much data? So like there's conversations that you kind of have to pull out of these requirements and say, that's not going to work, just in the back of your head.
Yeah, especially because, like you said, RPO, right? What exactly are we trying to synchronize here to over there? Will it really be ready in, real time so that we can actually say that the rest of the time is just the VMs coming up and database is connecting to whatever? Totally get it. You're right.
If I only have 5 minutes to bring this data up, I probably can't boot up 50. If it's 52, I probably can't boot up. I probably actually have to have it hot on that side with data writing to both sides to get a 5-minute failover. By the time, that's a tight window. So just things to kind of watch for that potentially are out there. So great, good job. All right, next slide here. So this is that kind of our final point here. Incorporate the current state of the customer environment into your logical designs. Requirement. The design should allow for N+1 in development and N+2 in the production environment. Okay, so that's our requirement. Remember, don't design until it's time. Pull back, look at all of what you have, right? So take a look again at our current state in environment and kind of study it for a second. And are there any things that could potentially affect my requirement? So to do that, like what comes into play in my logical design? Again, this is a little bit tough because we're not getting into the physical, we're not getting into all the other things that could potentially affect that. And it doesn't exactly give us all that we need in this particular question for the actual design. Like I would need to know numbers. I would need to be able to do some calculations that aren't given to me on this current state. But there is some information here that I can take away that is definitely going to affect my logical design. So I'll jump over here to again our answer here. But there's our requirement. Any thoughts on what, from just that quick overview, what would definitely play into? There might be more than one answer, but what could play into that requirement?
Elon, I've opened your microphone again.
Yeah. Okay. So you're asking actually what is relevant in terms of the vSphere?
Well, yeah, just given the requirement to allow for N+1 in development, N+2 in production, and then looking at I'll jump back here real quick, just looking at that current state environment that you were either given this design or you made it because they didn't provide it. What are some things that you might want to think, okay, well, this is going to affect the way I'm going to logically draw out this environment in my logical design?
In terms of the amount of hypervisors, for instance.
Mm-hmm. Yep. It's definitely gonna show how many hosts you have in each of your clusters for sure.
Yeah, this is what else? Amount of what else? I see data stores, for instance. I see.
Mm-hmm. Yeah. So one other thing that jumps out, and I'll jump forward here, is one way to draw this is like this: Site 1, Site 2. that's going to affect the way that their current state. If you look at their current state again, the application cluster or production is on the left, and on a completely different site with a 20 gig link is their development environment. So they asked for N+1 at the dev and N+2 at prod. There are different sites, right? So when I logically draw that out, conceptually I wouldn't have to worry about that, but logically I'm getting into more of the how things come together. Now I've got, again, I don't have to show full connections here, but logically I'm showing different sites, and I'm showing my cluster, and I'm showing the number of hosts within that cluster. I'm doing it with with pretty graphs, pretty icons, but I'm showing all that stuff, and then storage at both sites. So that is one example that how a current site environment might play into your logical design. You have to recognize that I've got 2 sites, and here are my numbers. I've done the math, and also, by the way, there are 2 sites. So. And so that's just one example of how to incorporate what the customer currently has into your design that you just might have to take into account, because we always have to be aware of what the customer has before we present a design. If the customer doesn't have fiber switches, you might not be able to use a fiber channel array, or you're at least going to have to justify why you wanted to buy fiber switches on top of all this stuff and implement fiber switches to put in a fiber channel array versus going something like iSCSI or NFS and leveraging what they already have. So just things like that. So, and with that, that's pretty much the end of my slide deck here. The only source that I have is, and I can send this out later if whoever wants it can just tweet me. This is a PDF for functional versus non-functional requirements. It's freely available on VMware's community site. It's a really good white paper. It's pretty short, and it's less technical. It's more abstract to help, again, kind of reinforce that functional versus non-functional fight that we all kind of have in our heads. So, and let's see. With that, my thank you slide is broken. It was supposed to say thank you. That's why you don't make the slide deck. You don't make changes to the slide deck just an hour before your presentation.
Now, listen, thank you so much. Basically, what I would love to do is if you make a blog post saying, I presented on vBrownBag, and these are the things that I used, and then I can put it in the show notes when we publish the recording, so people can also get to see where your blog is and find your other stuff. But honestly,
okay,
I loved it. I'm going to open the mic for Elon in case he has any other questions before we leave.
No, I'm right now in the process to study, to prepare myself to the DCD version 6.
Awesome.
So yeah, so it's really helped me. I hope that the example that you provided with Colorado and Chicago will be one of the questions.
It's a great example.
I doubt it. I made that one up. So if it is, that would be crazy.
Okay.
But it's something that we really value from the people that actually work at designing, that they provide real world examples. Because sometimes we only have like the official study guide, and everybody has that one example, and they have questions and they're not sure. So having more examples is always great.
Absolutely.
Yeah. All right, guys, I'll stop the recording. Thank you so much for attending live, Elon, and thank you so much, Paul, for presenting.
Thank you. Thank you both.
Bye-bye.